Hello everyone, how are you guys doing? And good morning. We're expecting quite a few people today, 16 I think, so we will wait till everyone arrives. Yo, it is freezing where I am. Okay, we would be starting now-ish, but it seems like a lot of people are late. But I do understand that it is a morning lecture, so we'll wait for everyone else to join. A Saturday morning lecture, no less. So But yeah, I won't wait too long, maybe like 2 or 3 minutes just to give people time to join. I imagine some people also, since there were so many new people on the group, maybe some of them hadn't created Zoom accounts yet. Suppose that's possible. Okay, while we wait though, let me start sharing my screen. Okay. So yeah, we've had some discussions on how to like improve the interactivity of online lectures and stuff. And one of the ideas that we had was these little quizzes. So I'm not sure if you guys can see it. It might be covered by this Zoom thing at the top. But the website, let me also just post its name in the chat actually. So I'll do that quickly. So you can visit www.menti.com. So I just posted the link in the chat, the URL. So if you visit that site and type in this code at the top right here, so 354112, you don't have to put the spaces. You can if you want to put them, but you don't have to put spaces. And yeah, so if you visit that site, it'll ask you for a nickname. It'll also recommend you a nickname. So you can use an anonymous one because it is like a little bit of a competition. So I'm not sure if you'll want other people to know what sort of moniker you're using. So yeah, you can pick an anonymous nickname, make it whatever you want. And yeah, it's basically like a little interactive quiz on the topics that we covered in last week's lecture that we'll be doing here. And yeah, as you guys join up, it'll show me who's joined, and basically like a little game. Why isn't it loading this participants tab ever? What is Zoom doing? Okay, we've got 6 participants. And yeah, you can access on a mobile phone as well. Any device that you want will work. Even the desktop or laptop that you're watching this on, you can do it in that as well. But yeah, use any device that you like. Why won't it show me who is participating? So yeah, we can do this while we wait. It seems like people are slowly joining on. So for those of you who hadn't joined yet, we are doing like a little interactive quiz thing that will just remind us and refresh us on what we learned in last week's lecture. A little bit competitive as well. So there's a link in the chat. I'll post it again just in case you can't see the old chat if you just joined. So there's a link in the chat, and if you go to that link and type in the code that you see at the top right of my screen here, 354112, you don't have to put the spaces. It'll take you to a site. You can put in a nickname. I think make your nickname anonymous, or I mean, if you don't mind, you don't have to. But yeah, you're welcome to make your nickname anonymous, and it'll basically just, it's a nice way for us to do an interactive quiz. You can use your mobile phone, your desktop, your laptop, your tablet, whatever you want to use will work. So yeah, if you can can do that while we wait. So yeah, I see 2 people have joined so far, so we'll wait for everyone to join this, and that'll also give more time for the other people to join the course. The lecture. So I see we're at 8 participants currently, and we are expecting like 16. I imagine we will have some absentees since it is a early Saturday morning, or somewhat early. It is early during lockdown. I don't usually wake up before 9 in lockdown, just because, you know. Okay, so yeah, we'll wait for other people to join. 2 so far. Are some of you guys having trouble with Menti, or are you just finding a device that you can use? We're at 8 participants so far. Cool. 3 in the Menti quiz thing. So yeah, if the rest of you could join the Menti quiz, I think we'll just get started with it since it seems like some people are very late, which isn't too great, but I suppose they can always catch up with the YouTube recordings. So yeah, go to www.menti.com on any device that you like and type in 354112. Put in whatever nickname that you want. They'll even recommend one for you. I'll get you. Okay, 4 people so far. Feel free to ask any questions if you're having trouble setting it up or something. But as far as I know, it does work on almost all devices, so you can pick whatever you like. See, another person has joined. So again, just in case they don't have it, menti.com 354112. Okay, 5 people. So I think 2 more people need to join, but we won't wait too long because we are super late. I'll start the quiz at like 9:10. I think this thing is quite fun. It must have been very difficult for them to make this app. Okay, I see another person has joined. That's good. So we're up to 9. Late, but all good. Okay, give them just a bit of extra time. Got like another minute or so. So if you go to www.menti.com and type in 354112, you'll be asked for a nickname, and you can put whatever nickname you want, and then you'll be able to join this quiz that we're doing. It's like a nice interactive quiz. There's only 5 questions, so not too hectic, but also probably a good way to get our brains working on a Sunday. Okay, I'll wait. Okay, 9:10, and I will just start then because I've been waiting for a while. Okay, cool. Let's just get started, and this will also give the other people some time to join. All right, so there's 6 of you participating. I guess that's not a bad number, so let's just go for it. So yeah, each question is timed. I'll read out the question as well. Int, double, float, string, and bool are all. So you'll see a bunch of multiple choice options will appear, and you can just pick which answer you think is appropriate. So here our options are variables, words, statements, data types, or names. So yeah, all of the questions are ones that we would be familiar with from last week. So good way to revise and also just to refresh your memory. and faster answers do give more points, hey guys. That's the other thing. And yeah, you've got 60 seconds per question. Interesting. Okay, I thought this would catch some people out. So yeah, data types was correct. So yeah, variables was the main trick one that I put in there. So when we create a variable, we will call it either int, double, float, string, or bool, or any of those other data types that we saw. But these things themselves are data types. They are not the variables. So all variables have a data type, but there is a distinction. But we'll explore this more today. So yeah, that's interesting that some people will call out. Okay, on to the next one. What structure do we use to provide a graphical representation of an algorithm? Nice. Okay, interesting split there. So yeah, flow chart is correct. So that's what we would call like graphical, because it's more, yeah, it's more like that. The decision table is what they would call a compact and readable representation of an algorithm, or a decision process rather. Because that's the other thing. The decision table, remember, doesn't represent the entire algorithm. It only represents the decisions that you make in the algorithm. Whereas the flowchart from the start to the end represents every single step in a nice graphical way. So also the other thing about these questions is they'll just familiarize you with how Microsoft frames these questions in the test, in the MTA test. And they are tricky about it. They are tricky. So don't be discouraged. Next question. What data type would you use to store an email address? Okay, interesting. So I'll go through what each, so yeah, string we use to represent a sequence of alphanumeric characters. Double represents numbers with decimal places. Char represents just a single character. So like one @ sign, for example, or one letter or one number. And int represents integers. So int stands for integers, char stands for characters. We went through a little bit about what double stands for, and string is basically like a long list of characters, which is what you would store an email address with. So nice on that one. And next question. What data type would you use to store an integer larger than that big number there, about 2.1 billion? What data type would we use to store that?
Just do it. Integer.
Interesting. Yeah, so the answer to this question, if you want more detail on it, is on page 9 of the MTA textbook. So the integer data type, the int data type, can hold numbers ranging between minus about 2.1 billion and plus 2.1 billion. If you want to store a number larger than this, you have to use the long data type. So long is like long numbers, basically. Cool. So the last question, you have 2 minutes. It's a typed question this time. It's might be a little bit challenging, but we'll see. I remember we did discuss it, so we'll see how it goes. On a 32-bit computer, the int data type uses bits of memory. So you have to just fill in the blank there. How many bits of memory will the int data type use on a 32-bit computer? You can take your time on this one. Faster answers will not get more points on this question.
Đây là quyết định đúng không?
I did think this one would be difficult, so I'll give a little hints since there's a minute left. So if you look on page 9, you would be able to find the size of an integer, but the size is given in bytes. So if you remember how many bits are in a byte, then you'll be able to convert that size into bits. Okay, let's see what everyone said. Okay, ooh, someone did get it correct. The correct answer is 32. Yeah. So yeah, one person got it. Well done. So I'll explain why this answer is correct. So the person who said 64, on some computers this would be true, but on a 32-bit computer, you're not gonna you can't hold a 64-bit data type. So that's that one. 4. So 4 is how many bytes you would use. So if you look on page 9, int uses 4 bytes. There are 8 bits in a byte. 8 bits in a byte. So 4 times by 8 gives you 32. So 32 bits. So you have to be careful with these questions about whether they're asking bits or bytes. 28. Interesting answer, but yeah, no. So I think one good way of remembering is that it's almost always going to be some power of 2. Okay, so it's either 2, 4, 8, 16, 32, 64. We wouldn't really work with a number like 28 in computing. But yeah, so whoever said 32, good on you. Good answer. All right, and so now there's like a little display thing. Cool. Cool. So well done to Damien. You won today's challenge. We won't do this every week, but I think it is quite a good way to like pass some time while whoever's late joins. Okay, so that's it for our little quiz. Hopefully it reminded you of some of the things we covered last week, and then also just woke us up for this morning's lecture. So I think with that, why don't we go on? I'm going to, yeah, we can close that. Cool. There's another new thing that I'm going to introduce you guys to today, like another new website. But we'll do that at the end of the lecture. And for now, we'll just continue where we left off last week. By the by, so okay, we've got 10 people here. So we are going to start taking register. Unfortunately, I haven't yet been given access to a I haven't yet been given access to the Excel spreadsheet with everyone's names. So if you could, can you just type your name in chat, the name that you gave Brighter Futures? If you just type your name here in the chat, then I'll be able to transfer that onto the register when I'm given access later today. So if you could do that, because there was someone with a strange nickname last week that we didn't know who it was. So yeah, if you could just type out your full name in chat, I'll be able to transfer that over to the register. So thank you for that. Okay, I'll leave chat open so that I can see if anyone asks questions through there. And guys, feel free to also ask questions over the microphone. I'll also be encouraging that more because I think it does improve like interactivity, and we get to know each other better, you know, through that rather than just typing in chat. But yeah, chat does work too. Okay, so last week we started with the sort of introductory lecture. So, you know, there was like a brief overview of the course. Obviously, we had to get going quite quickly. We covered two different types of decision structures, flow charts and decision tables. So hopefully you guys recall that stuff. We went through this sort of flow chart. We also ended up translating this into code. If you guys recall, this flow chart was given two numbers. It asked a question about the numbers and it output the larger number, whichever one was larger. So you can see this question, it's like if x is greater than y, then it would output x, and if not, it would output y. Okay, so this would find the maximum of two numbers. Okay, we went briefly through the structure of a C# program before jumping into variables. Okay, I think since there was a question about this, I'm just going to remind you guys of this as well. So a variable consisted basically of three different things. Okay, so there was the data type, which is what, if you remember in the quiz, we were asked string, bool, double, and int. What are they examples of? They're examples of data types. The variable is like this whole thing, or perhaps the name. But the variable is a placeholder for a certain fact or figure. Okay, so for example, number here would be an integer variable that's holding the value 42. Okay, name here would be a string variable holding the value Ali. And bool here, understand would be a Boolean variable, so a bool variable holding the value true. So we went through these and we discussed all of the different data types that there are in C#, and there sure are a lot of them. But we discussed them and sort of just briefly like why they would exist, what size they are, what they hold, and we went through some different examples of them. Okay, so following that, obviously being able to store information, store data, store numbers, facts, figures inside a computer is useful, and we use variables for that. But once we could do that, the obvious next step was to go, okay, how do we make decisions with these variables, right? Our goal here is to make a decision with these variables. So one of the most basic ways to make a true or false decision, or a yes or no, ask a yes or no question to a computer is called the if-else statement, the if-else statement. So we went through a few different examples of if-else statements. So in this one, we have like a variable called number that's holding a certain number. So it's an integer variable. And we can ask a number of questions about it, right? So we can say, is num greater than 6? Okay, is num greater than 6? And what the computer will do is it'll evaluate this condition. It'll evaluate that statement and it'll wonder, like, is this statement true or false? So if the variable number was holding 42, for example, well, 42 is greater than 6, right? So that would be true. And so the computer would then know that num's value is greater than 6. If the num variable was holding, say, the number 3, 3 is not greater than 6. Like if you say 3 greater than 6, that statement is false, right? So then we would know that num's value is less than or equal to 6. Because remember that if you say 6 greater than 6, that is false. 6 is equal to 6. It's not greater than 6. So that would also be a false statement, right? We could ask another question as well. So we could say num equals 6. Putting 2 equal signs there is asking the computer, is the thing on the left, is num, right? Whatever num's value is, equal to the thing on the right. So is num equal to 6? If that statement is true, then we would know that num's value is 6. And if it was not true, if it was false, we would know that num's value was not 6. Okay. And we also saw that you don't need the else part of the statement. If you only care about the truth of the question, you can just remove the else statement. Okay. The next thing that we have to cover, so that's where we left off last week, and then we translated that flowchart into code. The next thing that we have to consider is all of the different ways we can ask these questions. Some of you guys have some background noise, so if you wouldn't mind muting your mic if there's a lot going on. If not, I'll just go through and do it. So we have, you can see here in the condition at the top here, we have num, some funny sign, right? This is a greater than sign that you probably recognize from maths. And here we have num, and then, you know, another sign, equals. Okay, these weird signs in the center here are what we call operators. They are called operators. So it's just like characters or a sequence of characters that the computer assigns a special meaning. Okay, that the computer assigns a special meaning. So we just want to explore the different operators because they'll allow us to understand how to sort of communicate with the computer in a more effective way. So the next thing we cover will be on that. Someone, I can hear you like stirring soup or something. If you could mute your mic because it's a bit...
Should realize that.
So, cool. Let's get started. So there are quite a few different operators in C#, a lot of them, in fact, many operators. We won't cover them all today because I feel like that would get a bit boring, but we're going to go through some of the important ones because without them, we won't really be able to do much. So if you go to page 10 of the MTA textbook, page 10, the chapter was posted on the WhatsApp group as well, pretty recently. So you could find it there as well. You would see a list of all the operators. I have a list here on the slides as well, but I'm just telling you this so that you can refer back when we're not together. We will not be covering this whole table because it is very long. We will just cover some of the ones that I think are important immediately. So all of the different operators in C# have different names. So the first ones we're going to discuss are operators of equality because we've seen these before. So let's, and they're also pretty simple to understand because you're asking a pretty simple question with these operators. So I'm going to hop over to C#. Okay. Cool. So I'm in Rex Tester now. If you guys don't recall, or if you're new, we are using this as just a good way to get up and running very quickly so that you can start programming C# yourself. So if you go visit Rex Tester, you'll be given something like this, and it's very easy for you guys to get started and to just start programming. Okay, so, oh, sorry, I sent that privately accidentally. So let me just send it to everyone. There we go. So Rex Tester, I just posted it in the chat, or a link to it in the chat. So I've got Rex Tester open here, and we're just going to go through what these operators do. Okay, so we'll focus on these two first because they'll give you a nice sort of intuition about how the computer is working. So what I'm going to do is create an integer variable here. So I've said int x equals 6. Okay, int x equals 6. So all that is a placeholder. Okay, wherever I type x, that's the name of the variable. The name of the variable is x. Wherever I type x, it will be replaced with 6. Okay. wherever I type X, the computer will just see the number 6. Okay. And so yeah, the main thing that I want to be able to do with this is to make decisions. Okay. So we have a bunch of different kinds of operators. The operators of equality will allow us to see whether something is equal to 6. Okay. So let me show you what goes on here. I'm going to say console.write. Okay. So all this will do is print something out to the screen. So I'll show you what that does. I'm going to put X there. Okay. Remember, I told you wherever the computer sees X, it's just going to replace it with 6. Okay. So I'm going to go, I'm in Rex Tester currently. I'm going to come down here and click Run It. And when I run this, you can see it just prints out 6. Okay. So I said console.write. So this means write something to the screen, print it out to the screen. And I told it to write X, and it wrote out 6. Okay. So it knows that the value of X is 6. That's what I wanted to demonstrate to you guys there. Okay. So the next question is, what do these operators allow us to do? So what I want to try out first is to say equals equals, okay, and then say 6. Okay. Equals equals 6. So what I've told you about this operator is what it does is, and a lot of the operators work in this way. Okay, there'll be something on the left of this special sign. Okay. In this case, we have X on the left, right? And we have 6 on the right. 6 on the right. What the operator will do is take the thing on the left and ask whether it is equal to the thing on the right. Okay. If it is, then the operator will return true. If it is not, then the operator will return false. So let's see that in action. We know that X is equal to 6, right? We assigned that. Okay. So this will print out when I run it. You see it prints out true. So the computer knows on a logical level that X is equal to 6. Okay. And I can show you this in another way. If I say X equals 8, and I click run it, then the computer will say false. False. That is a false statement. 6 is not equal to 8, right? Cool. The next thing I wanted to say was just explaining why we have to do it this way, because I think particularly this operator will give you good intuition into how computers work. Okay, so you can see that there are 3 equal signs on the page, right, currently. Int x equals 6, so I use an equal sign on that line. And I have this x equals 8 here as well, okay? So 2 equal signs here and 1 here. What I want to show you is that the equal sign is doing something different here. Because you might say like, oh, why can't I just say x equals 8? Why wouldn't that just tell me whether or not the thing on the left equals the thing on the right? Well, because equals and equals, the computer assigns a different meaning to each of them. Okay, so it's like a language. It's like a language. This is a specific grammar that the computer understands. So what 1 equal sign does is it takes the thing on the right, 6, and it saves it into the thing on the left. Okay. So whatever you put on the right of a single equal sign will be saved into whatever you put on the left of that equal sign. Okay, so what this did was take 9 and save it in X. Okay. 2 equal signs will do something different. It will take the thing on the right and ask, is it equal to the thing on the left? If it is, it will print out true, and if it is not, it will print out false, okay? Or it will return false is the correct way to say it. All right, so with that explained, so that is the first operator that we have formally learned, and we're gonna go through quite a few of them, just for you guys to get an understanding of how we do this communication. I know this bit of the course, going through all of these different operators and learning all these different words and grammars can be a bit annoying, but I think it is worthwhile just getting out of the way so that we can get on to the more fun and interesting stuff without coming back to this later. Okay, so these are the operators that I want you guys to know. You might look at this and go, wow, there's a lot on the screen. But actually, it's quite simple and it makes a lot of sense. Okay, so the first ones are the operators of equality. There's only two of them. So we've seen equals equals. That just asks, is the thing on the left equal to the thing on the right? Okay, so is x, which is currently 9, equal to 9? And the answer to that is yes. Okay. If we made it 8, the answer to this would be no. So the way we evaluate this is just find out if it's true or false. Another question we can get the computer to ask is, we can replace the first equal sign here with an exclamation point. And how we say that, how you would pronounce that, is not equal to. So is the thing on the left not equal to the thing on the right? Okay, so how would we evaluate that? We can see here 9, okay, int x equals 9. So this x would just be replaced by 9, okay, like so. And then you just have to evaluate the truth of that statement. So when I tell you 9 not equal to 8, so 9 not equal to 8, that's how we say that, not equal. 9 not equal to 8. You can see that that is a true statement, right? It's a true statement. And you'll be able to see that the computer knows that it's true as well. So you see it says true. However, if I said 9 here on the right, so 9 not equal to 9, that's now a false statement. 9 is equal to 9, obviously. So when we print that out, the computer says it's false. Okay, so those are the operators of equality, so we can test whether the thing on the left is equal to the thing on the right. Okay, there are also, we've already seen these ones, so these ones will be easy to get through. There are relational operators. Relational operators. So we can go through some of these. And all of these you'll recognize from maths probably. So the relational operators, I'll type them here for just for easier access. There is the greater than sign, the less than sign, greater than or equal to, less than or equal to, and well, we'll get into the last one in a bit. Let's consider these ones first. Okay, these ones also quite easy to evaluate. You'll probably be familiar with them from any school maths that you did or are doing. So we can say x greater than 8, right? So what question are we asking of the computer there? Well, x is currently equal to 9, right? So this x is replaced by 9, and it's basically saying 9 greater than 8. Is that true? Is 9 greater than 8? Yes, it is true, right? 9 is greater than 8. So what will the computer tell us here? The computer will tell us true. Okay, and we can see if we made it 10, is 9 greater than 10? The answer to that is no. Right? That is false. So the computer can tell us if it's false. Notice how all of these are yes or no questions. Hopefully you guys can see that less than would work in the same way, right? Is 9 less than 10? The answer to that is yes, right? So true. And the computer will tell us true. Okay, see, true. Cool. And then we have greater than or equal to and less than or equal to. And hopefully you guys can see that that's because there are special cases here. Right? Like if I say 9 or x less than 9, right? X is 9. So is 9 less than 9? No, it's not, right? That is false. So we'll see that that's false, right? False. 9 is not less than 9. 9 is equal to 9. So what we can ask the computer instead is if we put an equal sign after it, it'll tell us is 9, so is x less than or equal to 9? And now the answer to this question will instead be true. And we could also ask it in the reverse way. We could say, is x greater than or equal to 9? So the answer to that question would still be true. Yeah, so hopefully you can see how to apply these. It's just a different way of writing them. Okay, and yeah, guys, feel free to ask any questions or to ask me to slow down if you need. Okay, so those are the 4 main relational operators. I want to introduce you to another one. might be a little bit complicated so far, but it is the word is, okay? C# knows what this word means, and how we could see that is if I type out is, you see it highlights it in purple here. So C# has assigned a specific meaning to the word is. And in order to show you that meaning, I'm going to go ahead and just create another variable here. So I'm going to say string. I'll save an email address in the string. So I'm going to make the string equal to say josh@email.com. Okay, so we have a string there, right? We have a string there. What is does, so again, like all these other operators, there's always been something on the left and something on the right, and we're able to evaluate that in some way, right? And you can see that with the equal sign as well. There's something on the right and something on the left, right? And each operator will do something different with the thing on the right and the thing on the left, right? Each one has a different way of working with them. And is no different. So we would say is here, is. And what this does is on the left, you give it something, anything, okay? A variable or a type or anything like that. You give it something on the left. And as usual, you're going to give it something on the right. So the thing we give is on the right is a variable type, a type, okay? So I can say X is int. And in order to just get you guys participating, can anyone tell me what you guys assume the truth value of this statement is? When I say X is int, is that true or is that false? Just from your intuition. Anyone know? Did you say true? True, yeah. Sorry, I couldn't quite hear. Yeah, so this is a true statement, right? Why? Because you can see here, X is an integer, right? We see int there. So when I say X is int, and you can read it like you do in English, that's a true statement, right? That is a true statement. X is int. X is an integer, okay? And you can see that the computer will be able to translate that into the word true. Okay, so X is int, that is a true statement. And we can try with another thing just to confirm it's working. If I say X is string, X is string, that's now false, right? X is not a string, X is int. X is int, it's not a string. So I can run this and you'll see it prints out false. And we can do the same with email, right? If I say email is string, so you can see email is our variable here. That's the name of this variable. And it is a string, right? So this will print out true when it eventually runs. There you go, it prints out true, okay? And I can just, as one last check, I'll say email is int, and you'll see that that will print out false, okay? So that's what is does. Don't worry too much about this now because we will see it again later, but I just want to introduce these ideas to you. So those are our relational operators. We're going to skip over, ooh, I don't know why I did that. I must just change this to multiplicative, or I'm just going to call them mathematical. There we go. Sorry about that. Okay, I'm going to skip over the ternary operator for now, and we're going to go straight to these mathematical operators. Okay, so there are 2 additive operators and 3 multiplicative operators. Don't worry about all the words. I think these ones will probably be the easiest to understand. But what I want you guys to start picking up on is that there is a pattern here. So now I'm going to go ahead and create 2 variables. So int x equals 9 and int y equals 10. Okay, we won't use them just yet, but we need those 2 variables to demonstrate what these guys are doing. Okay, these mathematical operators are what they sound like. They're exactly what you would expect them to do. Okay, if you think about a calculator. So we'll go through them all. There's plus, minus, asterisk, dash, and this percentage sign is what we call modulo. Modulo. So I'm going to say I'm going to type, once again, I'm just going to type them here for easier access. There is a plus sign, a minus sign, a asterisk, a dash, and a percentage sign, a mod. Okay, so what these do is exactly what you'll expect them to do. Okay, so I'm going to say console.write 2 plus 2. 2 plus 2. This, hopefully you guys will have some intuition about what this is going to print out. What I want you to also start picking up on now, though, is the more fundamental pattern. Okay, like with the equal sign and the equals sign and the less than sign, there is always something on the left and something on the right. And depending on what operator we put in the middle, it will do different things. Okay, it will do different things. So in this case, 2 plus 2 is obviously going to take the thing on the left and add it to the thing on the right. And when I click run it, it's going to print out 4. Okay, pretty straightforward stuff, I think. And we can do it with variables as well. So you see we have these variables here, x and y, they're integers. If I say x plus y, that is going to take the thing on the left, which is 9, and the thing on the right, which is 10. And if we're lucky, or if we're correct, it's going to print out 19, correct? So it runs, and you can see it prints out 19. So that's what we would expect it to do, right? Now, hopefully, some of you have been wondering, it's like, okay, well, this makes sense for maths, right? For maths, we can say x plus y, and if x is a number and y is a number, it makes sense what we need to do, right? But hopefully you guys remember there are a lot of different types in C#, right? We also have strings, okay? So what if I create 2 strings? I'm going to create one string called word1 and another string called word2, okay? And I'm going to make the first word equal to dog and the second word equal to cat. Okay, cool. So we saw what happened when we said x plus y, when x was 9 and y was 10, right? But what happens when I say word 1 plus word 2? Right? We know that the plus sign, so the plus sign in a mathematical world, like in maths class, it makes a lot of sense what it does because we only use it with numbers. But remember that in C# we have all of these different types, and you need to, if you define something, you need to define it for a lot of different contexts. So what will the plus sign do in this case? Does anyone have any guesses? Do you want to go ahead, or maybe you're following along and you actually already know the answer? But what do you guys think would happen here? Does anyone have any intuition? When I say dog plus cat, what will C# do? Because that's quite confusing to a human as well, right? Ooh, someone's Wi-Fi broke, so that's a pity. Okay, anyone have any idea about that? You'll actually probably find that the intuitive way you handle this is in fact how C# will handle this. So I had the 2 numbers here. So you can see it goes dog, cat, dog, cat. Okay, dog, cat. So it just takes the first word and the second word and just joins them together, just throws them together. All right, so that's how we add strings in C#. If you say string 1, word 1 plus word 2, it's just going to throw them together like so. Okay. So not a bad way of handling it, I don't think. Okay, so it gets dog, cat. Awesome. So with that sort of covered, that's the plus sign, and hopefully you can see that a lot of different things work out. Yeah. So in that case, we were adding strings, right? So it added the 2 words together. So yeah, quite right. I have a problem logging into Rex Tester. Okay, well, hopefully we can handle that in the break. We will be on break in like 5 minutes as well, so we'll handle that kind of thing. All right, so the next thing is to say, just let's quickly go through the next additive operators and the multiplicative operators. So we'll say 15 minus 10. Hopefully I don't have to explain this to you, but again, guys, keep the broader pattern in mind here. There is something on the left and something on the right. This operator in the middle has a specific meaning. The minus sign has a specific meaning. And what it means is we take the thing on the left and we subtract the thing on the right. So 15 minus 10, and that'll work exactly how you expect. It gives us 5, okay? And you can put a variable on the one side as well. If I put y on the left and 5 on the right, y is just a placeholder, right? Int y equals 10. So this y will be replaced by 10. The thing on the left is 10. The thing on the right is 5. The thing on the middle is minus. So we get 10 minus 5, which is, of course, 5. And we can see when we run it, it prints out 5. No problem, right? And yeah, you could also have a variables on both sides. Y minus x will give us 10 minus 9. So 10 minus 9, which is, of course, 1. 1. And also, it can go negative. So this is the other thing that I just want to show you guys. If I say 5 minus x, so that is 5 minus x, which is 9. So 5 minus 9 is, of course, minus 4. And the computer can handle those negatives, which is quite clever. Because remember, it's converting all of this to binary. So this is quite a difficult thing, which we'll experiment with later on in the course. Okay, so that is plus and minus. 2 more things to cover before we'll take a little break. I want to just show you what asterisk does and what dash or slash does. Okay, it's probably quite intuitive to you. It's not a difficult thing. We might have to explore them a little bit though, because there are some tricks, I suppose you could say. So if I say 2 asterisk 3, what do you guys expect that to do? You've probably seen this notation before if you've ever worked in like Excel or like ever done maths on a computer pretty much. Asterisk is how we write times on a computer, right? So like multiply. So you take the thing on the left and the thing on the right and you multiply them together. So we're saying 2 times 3, which is of course 6. Okay, 6. Another thing that I want to show you guys is that it does know, you guys remember what BODMAS is? You know what BODMAS is? BODMAS, BODMAS. Ooh, sorry, I posted that on the private chat again, BODMAS. Okay, so that is brackets of division, multiplication, addition, and subtraction. C# does know BODMAS. Okay, it does know it. So multiplying must come before addition and subtraction. So we can experiment with this. I'm going to say 7 minus 2 times 3. Okay. The correct answer to this question is 1, right? The correct answer is 1, right? Because we don't say, if you said 7 minus 2, that would give you 5, times 3, that would give you 15. That's wrong. You do the multiplication first. 2 times 3 is 6. 7 minus 6 is 1. And C# does know how to do that correctly. You see it prints out 1. 1. Okay. And you can see that it also knows how to use brackets mathematically. So if I throw 7 minus 2 into a bracket, it kicks that up to 15. Okay. So it does know BODMAS. C# does know BODMAS. So remember that. Okay, so yeah, quite a lot to take in. We're going to take a break now and then come back and handle division. But now we know how to do addition, subtraction, and multiplication in C#. Last thing to cover is division and this special thing called modulo. And we'll have one more operator to cover and we'll finally be able to move on with the more interesting stuff. This is like the vocabulary part of a language course. You know, at some point you just have to go through and learn what all the words mean, which is a little bit of a drag, but it is obviously important to learning the language. So yeah, I think let's go ahead and take a 10-minute break. so that we can recharge. We'll come back at 10:05 and continue with the rest of the day. If you guys have any questions, you're welcome to post them in the chat while we're on break. I am just going to go run and grab some water quickly because I'm a bit thirsty now. And yeah, I'll be back just now. We'll get started again at 10:05. Ooh, yeah. So someone asked, can we subtract things? I will just go through that again. I know we are going quite quick, so we can do it again. So I'll say, like, we do call, so subtraction is like a special kind of addition, we could say. Like they are both these additive operators. So yes, 3 plus 2 will add, 3 minus 2 will subtract. We did cover it briefly, and then we went negative as well, and you can use variables on both sides too. Wait, Christopher, are you there? Did you see that, or must I explain it again when we finish the break? So yeah, plus, minus work exactly how you would expect them to work. Subtract strings. Okay, I read the question incorrectly. I read subtract things. Okay, so no. Very good question though, but no, you can't. C# does not define that. It'll complain, I think. I did test this with another class as well, but let's just go ahead and try it. But yeah, very good question. Shows that you are thinking about it. You can see minus operator cannot be applied to operative type string. Okay, so no, it won't allow you to subtract strings, which makes sense, right? Because subtraction would be a very difficult thing to define in terms of strings. Some programming languages, not C#, some programming languages do define it as the group removal. So you would say like whatever letter is in A If it's in B, then remove it. Some languages do that, but C# is not one of them. C# just gives you this error. Cannot be applied to operands of type string. Okay, but yeah, good question. Yeah, sorry I misread it at the beginning. I read, can you subtract things? Okay. So let's get started again. So we've been going through these different operators. We just have a few more to cover. So we just finished covering the multiplicative operator, or the first multiplicative operator, which is times. So 2 times 3 works exactly how you would expect. Once again, just to remind you guys, you can do it with variables. There can be variables on one side or both sides or whatever. So we can say x times 3, x is 5. 5 times 3 is, of course, 15. And you'll see that C# manages to evaluate that just fine. We could also do x times y, which of course would be 5 times 10. Ooh, you can't hear me. Can other people hear me? Are things okay? Or should I turn up my mic a little bit? So I just turned it up a little bit. You can hear me, Yusuf? Okay, cool.
I can hear you fine, yeah.
Okay, cool. Other people can hear me. I mean, obviously, if Mabel can't, then telling her that other people can she wouldn't hear it. So I don't know. Maybe has she muted her speakers? I don't know. Sorry about that. I'm just trying to. Can you hear me now, Mabel? Or still low sound? Or sorry, I didn't quite hear you. Okay, well, I think let's go. So X times, yeah, okay, cool. Thank you. Yeah, because the others can hear me, so not sure. Okay, cool. Fantastic. She's back. So let's get started again. So we can also say X times Y, and yeah, it works exactly the same as multiplication, or it is multiplication. So yeah, nothing too hectic. Once again, negatives do work as well. So I can say int X equals 5, int Y equals -10. And when we do that, we get -50, right? So all of those BODMAS rules that you guys would have learned, still apply. Okay, so negative times a negative is a positive, positive times a negative is a negative, positive times a positive is a positive. All of those normal maths rules apply in C# as well. Okay, so that is times. And as you might expect, division also just works, although there is some sort of subtleties that we have to cover based on types again. So I do want to do that. But hopefully you can see if I say 10/5, what that is doing, there is something on the left, there is something on the right. What slash means, we take whatever's on the left and we divide it by whatever's on the right, right? It's sort of like what you would look at as a fraction. Okay, so 10 divided by 5 is of course 2. Okay, however, there is a subtlety here. Do you guys remember what data type, can anyone tell me, what data type would I use if I wanted to store a number with decimal places? Does anyone remember that? What data type would I use if I wanted to store a number with decimals?
Double? Double,
precisely. We would use a double if we wanted to store a number with decimal places. And that brings in a little bit of a subtlety with multiplication and division, division in particular, in fact. So what I want to show you guys quickly is just what that would mean when we are working with these things. So I am going to create another variable, z. Okay, so I say int x equals 5, int y equals 10, int z equals x divided by y. Notice that z is an int, okay? It is an int. So when I do this, it gives me 0, okay? I could make it easier numbers. Okay, so 5 divided by 10 is obviously the same as 1/2, but actually let me just make it easier. Okay, so we'll say 1/2. Okay, so you guys notice that that is not correct, right? 1 divided by 2, so let me just go through it. So we say int x equals 1, int y equals 2, int z equals x, which is 1, divided by y, which is 2, right? 1 divided by 2 is not 0, right? We can very confidently say that, okay? The reason why C# is telling us 0 is because an integer, this integer variable, cannot hold decimal places. It can't do it. It doesn't understand decimals. Okay, so it just ignores everything after the decimal place. All right. So there is a bit of a subtlety here that we have to work around when using division. And you can see that even if I make z a double, it still won't do decimals because both x and y are integers. Okay, so you have to be very careful about division because it is something that is, you know, more subtle than these other operators. Okay, because there is the potential to introduce decimal places. So now I'm going to make just y a double. So y is now a double as well. So y and z are doubles. So x divided by y, which is now a double. Okay, and you can see now it gives us 0.5, which is what we would expect, right? That's the correct answer. 1 divided by 2 is 0.5. Okay, so there is this little subtlety here that if we are using integers to store stuff, the decimal place will be ignored. Sorry, because now if we are using integers in division, decimal places will be ignored. But as long as one of the variables on the right, in the expression that you have on the right, as long as one of them is a double, the type of the thing will be a double. The entire expression will evaluate to a double, so the decimal will still be there. Okay, so that's one little subtlety that we just have to clear up when working with division in any programming language. If you are storing things in integers, you must not expect decimal places. Okay, they will not be kept. They will be totally ignored. All right. Okay, so that covers division mostly. There is one more thing that you would not be familiar with from maths, from other maths courses or non-computer science maths courses. And that is this little percentage sign here. Okay, what this is, it's called modulo. This is called the modulo or mod. And it's very interesting. Might be a little bit confusing if you're not familiar with how computers work and just with that mathematical concepts in general. But hopefully you'll be able to adjust and see what's going on. Okay, so what we would say when you see this, you say the thing on the left modulo the thing on the right. So 10 mod 2 or 10 modulo 2. And what this means is when you take you guys know what remainders are. Like hopefully you remember what a remainder is. So for example, if I say 11 mod 2, what this would do is give you the number, the remainder when you perform that division. Okay, so for those of you if that doesn't make sense, let me explain it this way. What you would do is say, how many times does 2 go into 11? The answer is 5, right? It goes 2, 4, 6, 8, 10. Okay, cool. So it goes into 10 correctly. And then we would say 11 minus 10 is 1. Okay, so we would say that this is 1. Okay, and so when I run this, you'll see it prints out 1 because 2 goes into 11 with the remainder 1. Okay, a little bit interesting, maybe a bit confusing, but trust me, it's very useful. This idea is very useful. So what this will give you is the remainder. And you can see, so if I say 5 mod 2, that has remainder 1 as well. And we can have 4 mod 2. Okay. And you notice I'm using mod 2 a lot. And the reason why is because mod 2 is something that we would use very frequently. This is how we can very easily gain an understanding of what even and odd numbers are. Okay, so I just want to give you an idea of where we would use this. All right, so if you say something is mod 2, so something mod 2, if the remainder is 0, then you know it is an even number. If the remainder is 1, then you know it is an odd number, right? So that's why mod 2 is useful. And yeah, the other parts of mod also have very useful features. Sorry about that. Okay, so we can do some other examples. Let's say, let's pick an interesting one. So we'll say 18 mod 4. 18 mod 4. So how do I evaluate that? We'll say, all right, we have to find out how many times does 4 go into 18. So 4, 8, 12, 16. Okay, so it goes into 4 times and it uses up 16. Okay, 16. It can get to 16. If I added one more 4, we would get to 20. Okay, so we can't do that. So this is 2. There is a remainder of 2, right? 18 minus 16. And we can see when we run it, it gives us remainder 2. All right, so that is what modulo does. It literally just gives you the remainder. Okay, if you divided the thing on the left by the thing on the right, then it gives you the remainder that you would receive. And for those of you just wondering about the special case, if it's something smaller, then the remainder is the entire thing, right? 3 mod 4 is 3. Okay, so it's obviously just the entire thing. And obviously 4 mod 4, that is remainder 0, right? No remainder. Okay, so those are the primary operators that we will need to know. There is one more interesting one, this ternary operator. I think let's discuss it in a little bit. It's pretty mean, so I want to leave it and get on to some more interesting content before we run out of time. So we will come back and discuss some of these other operators eventually, but those are the primary ones that you need. The ones that we have covered so far are the super important ones. Okay, so let's, I suppose we could do ternary since you guys do know what an if statement is. No, I don't want to. It doesn't make sense to cover it in that way. Okay, so what we are going to do is move on with our discussion of C#. We've got some extra tools now in our toolbox that we can use, and we will go right ahead. So with those operators covered, we now know how to ask we can do pretty complicated things now, right? With all of those operators, we're able to, like, we've got a lot of ways to encode different logic into the computer, right? I hope you guys can see that. So we have all of these different data types now, so we can store a bunch of different information in the computer, and we have a bunch of operators so that we can operate on that information and evaluate that information, okay? One inconvenience that we haven't yet gotten around is how to store lots of things, okay? So let me give you a quick example of where this might be necessary. So let's say I want to store 5 numbers, okay? I want to store 5 numbers. Well, we could say int num1 equals 5, right? Int num1 equals 5. I could say int num2 equals 6. Int num3 equals 7. Int num4 equals 8. And int num5 equals 9. Right? So you guys can see I've now stored 5 numbers in C#. Hopefully you can agree that that was a little bit, it seems a little bit silly, right? Like we had to do this much typing. You can imagine if I asked you to store 20 numbers or 40 numbers, is that going to take 40 lines of code? That seems a bit unreasonable, right? I think you can agree. So there is a faster way we can do this. What we would want to be able to do ideally is to just store a list of numbers, right? A list of integers, or you can imagine the same with words, right? Let's say I wanted to store a few different animals, right? I could say string animal 1, equals, let's whale. String animal 2 equals dog. String animal 3 equals cat, right? You can see, like, if I was going and storing a list of, or like 10 animals, this is a lot of typing that is totally unnecessary, right? Or seems totally unnecessary. So what I want to quickly introduce is a way that we can encode this much data in a much faster, more efficient way. Okay? And the first way we'll learn to do that, to store these groups of data, is called an array. It's called an array. Okay? So we have our whole collection of data types here, and you can see there are a lot of them, right? And we discussed this list last week. But we're now going to add another block, okay, just at the top here. And it's just going to be there to remind us that any data type can be turned into a list of itself using this sort of symbol here. So what that is, if you can't see it there, it's a bit difficult to see in the slide. That is a square bracket and another square bracket. But you'll see it in the code and it'll make more sense then. But the idea is, right, so you can say int number equals 6 or int x equals 6, right? You know how to create a variable like that. We've been working with that today quite a lot, right? And instead of just storing a single number, I could turn that into a list of numbers, okay? So I can say int followed by 2 square brackets, so open and close square brackets, numbers equals 6, 5, 10, 3. Okay, and I've now got a list of numbers. All right, and we'll experiment with how to work with these lists as we move through the course. Okay, so that would allow me to store a list of integers. Okay, or what we formally call it is an array of integers. The other word that they'll use in the MTA course is they'll sometimes call it a collection. So they'll say, how would you store a collection of integers? And you would say, I would use an array. Okay, I would use an array of ints. Okay. And we can do it with any data type. This works with all of them. So you can say string name equals Ali, right? And if you wanted to turn this into a list of names, instead of just a single name, you would put square brackets after the string names equals Ali Josh Mayer. Okay, so that allows you to store a list of strings. Okay, makes sense. And you can do that with any data type you like. Any data type you like. Obviously, the next important thing is to go, okay, well, how do I actually work with this list of things, right? Like, it's all well and good being able to store 5 or 10 or 100 numbers, but how do I actually access them? How do I actually access them? So we'll see that on the next slide. So let's say I have this, this array of strings here, this string array. Okay, Ali Josh Mayer. So the name of the array, like with other variables, and hopefully you can see it is very similar. It's still our template, right? We have a data type. It's a special data type this time. It has these square brackets after it, which means it's going to be a array of the data type. Okay, a list of the data type or a collection of it. We still have a name. So the name of our variable here is names. We could have made that anything we wanted, words, you know, whatever name we chose really, equals, and then we have a value on the right. Okay, the value of this, it happens to be a list of values or a collection of values, but it's still a value. So this is still our template. This is how we create a variable normally. Hopefully you can see it's very similar to saying int num equals 42 or string name equals Ali, right? It's very similar. It's still just a list. So how do we actually work with this list? Well, you've got this name here, right? Names. Names is the name of this array. And we can access each item in the array using its index. That's what we call it. We use an index to access these items. So for example, if you say names, and then you put these square brackets and you put a 0 in it, a 0, the number 0. So names at index 0 or names at position 0, that will give you Ali. Okay, names at position 0. All right. And you can do this with the other positions in the array as well. So if you say names in position 1, okay, names in position 1, that will give you Josh, right? If you say names in position 2, that will give you Maya. Okay. The important thing to remember here is that when working with arrays, we always start counting at 0. That's the trick. Okay, you start counting at 0. The first position in the array is at index 0. Okay, so this is position 0, position 1, position 2. And that's always, it's always done that way. Okay, we will explain later once we get to chapter 3, which is a very long way away. But when we get to chapter 3, you'll gain a knowledge of why we start counting at 0, like why we do it that way. But for now, what you must know is that we do. Okay, we start counting at 0. All right, let me just show you that quickly. We'll code up some examples of this and actually work with it. And I'll ask you some questions about how this would work. Okay, so we've got 5 integer variables here. And what I'm just going to do is convert them into an array quickly so that we can see what's going on here. So we can say int numbers, okay, int numbers. But remember, in order to convert it to an array, we need these square brackets here. So int followed by an open square bracket and then a closed square bracket. So what that would mean, so you see with all of these other ones, I just put int, right? Int, 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 int. Now I'm putting int followed by square brackets, which is to say this is now a list of integers. It is an array of integers, a collection of integers, right? And I can say equals these curly brackets, okay, curly brackets. And I just just put all the numbers there that I want in a list separated by commas. Okay, so we'll say 5, 6, 7. I'm putting the spaces so it's easier to read. C# does not need the spaces. Okay, it won't break it, but it doesn't need them. Okay, 5, 6, 7, 8, 9. And so now you can see in one line of code, I can store all of the integers that we wanted. Okay, and likewise, I can do the same with the string. So I had string animal 1, animal 2, animal 3, a bit of a hassle to work with. Instead, I can just say string followed by square brackets, right? Open, close square brackets. Animals equals curly brackets to open up a list. And then we can say whale, dog, and cat. Notice they are strings. So I still need to put the quotation marks, okay? C# will not know what's going on if those quotation marks are not there. If the quotation marks are not there, then they are not strings. C# will complain that you can't use those as strings. Okay. All right, so we've got that. All right, we've now got 2 lists. And what we want to see is we just want to work with them a bit now. We just want to work with them. So what we'll do is just try printing out a few things. So I'm going to say console.write. Hopefully you're familiar with this command now. So that's just going to say print something out to the screen. Okay, print something to the screen, write it to the screen. Okay. So what we're going to print out is say numbers in position. Can someone tell me what number do I have to put here in order to print out 7? Okay, I want to access 7 in this array of numbers. What index do I have to access it at?
2.
2.
100%. Exactly, guys. So 0 would give me 5, 1 would give me 6, 2 gives me 7. Okay, and so let's go ahead and double check that we are correct. And you can see we are. So that prints out 7, right? So hopefully that gives you a good idea of how these arrays are working. And we can do it with animals as well. So if I say animals in position 0, that will give me whale, right? It will print out whale. So I'm going to click run, and you can see it prints out whale, right? So that that is arrays. And yeah, you can do it with any variable type. You just throw those square brackets after it, and you give it the list that you want to be represented. There are other ways to do this. Obviously, yeah, hopefully you guys can even sense that there are some things are being hidden for now, and that's fine. We will cover this in much greater detail in chapter 3, but for now we just want like a working understanding. Okay, cool. So that covers arrays. All right. The next thing I want to discuss is, so yeah, we are working through the initial parts of the course quite quickly here. So we're going to have to jump around so that we have more time when we get to slightly more complicated stuff later on. So we are going to, but I guess actually the jumping around will keep things interesting. So what we're going to talk about now is sort of more complicated decisions, okay, more complicated decisions. And we are still going to be using, yeah, we are still going to be using some standard variables that we are familiar with, and just going through this next topic. I know it might seem a bit sort of disorderly, but I do think it makes sense covering it in this way. Okay, so we will get cracking on that. Okay, so I'm going to remove our arrays for now. Hopefully just keep those in the back of your mind that we can store a list of things, because we will be working with it before we finish chapter 1 a little bit. Okay, so the next thing I want to cover is a pretty important topic that allows us to make more complicated decisions. Okay, we've now got a more complicated way of storing data. We also want a more complicated way of making decisions. So for now, what we've covered so far in terms of making decisions is the if statements, or the if-else statements, if you like. So it looks something like this, just to remind you guys. Okay, if-else, right? And in this first bracket here, you'd put some kind of condition, right? Some kind of condition that evaluates to true or false. And you know a bunch of different operators. So we can now ask a bunch of different questions, right? You could say like, is, let me do this. So I'll say int x equals 10, right? So we've got this integer variable. We can ask a bunch of complicated questions about this integer variable with all of the different operators that we know, right? I could find out if it is an even number, right? I could say, is x mod 2, right? You know what that does? That will return the remainder, right? The remainder. If I say, is x mod 2 equal to 0? Is x mod 2 equal to 0? Looks a bit scary, but let's think about what this would do. It would say, okay, when I divide x by 2, what remainder does it give me? Hopefully you can see that whatever integer I am dividing by 2, it's either going to have a remainder of 0 or it will have a remainder of 1, right? There's no other option because all numbers, it makes sense, right? They're all at least 1 from one away from a multiple of 2. Hopefully you can see that. Pick any number, right? Any integer. Okay, so when I say x mod 2, this will, and if it equals 0, so if there was no remainder when I divide by 2, what does that mean about the number, guys? Do you guys know? From intuition. If you divide something by 2 and there is no remainder, what does that mean about the number?
It's an even number.
Exactly. If we divide something by 2 and there was no remainder, then it means that there was an even number. So what we can create here using a simple if statement, right? Using a simple if statement is something that can tell us, an algorithm that can tell us whether any number is even or odd. Okay. So, and you can imagine, we can ask very complicated questions now, right? Or fairly complicated questions. We can ask if it is greater than a certain thing, if it is equal to a certain thing, if it is greater than or equal to a certain thing, okay? And we can do a lot of different manipulations with all of the different operators that we have. However, what you might notice here is that we are still, at best, only asking yes or no questions, right? It's always either true or false, right? Any condition that we put here, currently, there's those two options. We only have those two branches, yes or no. So you can picture it, this is one diamond. It's one diamond. Okay. So hopefully you can see why this isn't necessarily ideal, right? We want a way to be able to ask more complicated questions, right? So as an example, let's consider a question where we want to see if I give you, I'll give the computer a character, okay? I'll give it either N, S, W, or E, okay? North, south, west, or east, okay? And based on the character I give it, I want it to print out the corresponding word, okay? So if I give it north, it must, if I give it N, it must convert that to the word north, okay? If I give it S, it must convert that to the word south, okay? So hopefully you understand the problem that we're setting up here, okay? And the same for W and E. Okay. So let's just explore quickly. While we only have if statements, how exactly would we begin to answer this question? Okay. We might say something like, if, so we'll have a character, obviously. So we'll say char, I'll call it direction, equals, and I'm just going to make it N for now, right? So if we wanted to do it with an if statement, we might say something like, okay, if direction equals N, right? If direction equals N. So what is that saying? It's saying if our character called direction is the same as N, then what would we want to do? Well, we would want to print out north, right? So we'll say console.write north. Okay, console.write north. Fairly straightforward, right? Now, the issue with doing it this way, so you can picture we've got 4 options here, right? So we would need at least 4, or maybe you could see how we could use 3, but we're going to be using a lot of if statements. Hopefully you can see, right? We would say like, okay, else if, or maybe we would say just another if statement. We could say if direction, oh, what the hell? You guys can still hear me, right? Sorry, I don't know why, but Zoom just logged me out. I think it's because someone else logged into the Brighter Futures account. Can you guys hear me? Are we still all good?
Yes, sir.
Okay, good.
Yes,
Thank you very much. Yeah, sorry about that. I don't know why Zoom just logged me out. Okay, yeah, sorry about that little interruption. Okay, so you can see we could ask for every single direction, right? We can say if direction equals S, and then we can say console.write south, right? Console.write south. Okay, and so we could go on. Hopefully you can see how this would be it's not a bad problem to solve, right? Not a bad problem to solve. There are more complicated cases, right? Like for example, if I wanted the user to be able to type in the name of an animal, right? Like let's say we want the user to be able to type in the name of an animal, and we want to print out that animal's sound, like the sound that the animal makes. You can picture that then we would have way more than 4 cases, right? And we would need a ridiculous number of if statements, right? A lot of if statements to actually go through that whole list of possible animals, okay? So C# provides an easier way to handle this. Okay? It provides an easier way to handle this, and that's what I want us to experiment with now. It will be the last thing that we cover for today because I do need to introduce you guys to this other cool site that you'll be able to do some practicals in at your own pace. So we might not be able to finish it in the greatest of detail, but the way that we could do this is something called a switch statement, okay? So what this would allow us to do is to evaluate all of these different conditions, okay? So we could say, I'll just type it out for now, and hopefully you'll gain some intuition about what it's doing. So what we say is we type the word switch, okay? And again, it's highlighted in purple. So C# assigns a specific meaning to that, exactly like the word if, right? When we type out if, that has a meaning in C#. Switch does as well, okay? What switch expects you to give it is a variable to work with, okay? So it needs a variable to evaluate. So you tell it, okay, I am switching over this idea of direction, okay? Over this char called direction, okay? You then open up some curly brackets, the same as we do with the if statement. Hopefully you can see it has a similar structure, right? With the if statement, we say if condition, right? And then we put these curly brackets. The switch statement is similar, right? We're saying switch direction, okay? And you give this switch statements a number of different cases. And it just makes it much easier to encode the way that we were thinking earlier. So remember, we wanted to handle these 4 cases, N, S, W, and E. And you can imagine there being a lot more cases. You can imagine there being way more cases than that. We'll see a few other examples of switch statements as well before we move on. So we can say like case, okay, the word case. You can see it's also highlighted because this again has a specific meaning in C#. And we can just give it a specific case, okay? So if it finds N, I want it to print out console.write north, okay? Cool. A special thing we do here, I'll explain what this word means in more detail at some point, but we say break. Okay, what that basically means is break out of the current case. Okay, so you're done. You're just telling the computer that it's done with that, done handling that particular case. Okay, so it breaks out of these curly brackets here. Okay. And now it's very simple. You can just give it as many cases as you want. Okay, console.write south break. Okay. And so what this is going to do is it takes the variable direction, it goes to the first case it sees, and it goes, okay, is direction the same as N? If it is, then it'll print out north and it'll stop. Okay. If it's not, it'll go to the next case, right? It'll check the next case. It'll say, is direction the same as S? If it is, then it'll print out south and it'll break. It'll stop. Okay. And you can see that we can just add as many cases as we want, right? Console.write west and break. Case E, console.write east and break. So we've handled a whole lot of cases here. You can imagine this would have taken 4 if statements, and we've got a structure where it's very easy to add further cases. Another powerful thing that the switch statement gives us the ability to do is define something called a default case, all right? So what this will do is it'll go through every single case possible. So it'll say, Is it N? Is it S? Is it W? Is it E? And you could imagine we could add NE, SE, WE, WN, right? Or sorry, WN is not actually a valid direction. But you know what I mean. We could go through all of the different directions that you could find on a traditional compass, and we can define them all, right? And we can define them in a very easy way without adding this whole new statement to the code. But what this also allows us to do is to go, okay, if none of the conditions were valid, so if it's not N, it's not S, it's not W, and it's not E, then we can define a default case, like a catch-all case. So we can say default, okay, default, like so. And by default, we can say if none of the other cases were found to be correct, then we can just tell it to say, sorry, that is not a valid direction. That is not a valid direction. And break. Okay, and that's, yeah, I do give you that in the slides, yeah. Cool. So we are able to define this default case. So let's just experiment a little bit with how this works in practice. So I'm gonna just go out of full screen quickly. And you can see that currently when I run it, direction is set to N. So it'll go to the first case, it'll check if it's N, and it'll go, okay, it is console.write north, and then break. And you see it prints out north. Pretty good. And you can see that as I change direction through all of the different options, so if I say S, it'll go south. If I say W, it will go west. If I say E, it will go east. Okay. And because we have this default catch-all case, if I put anything else, so if I put like X, it will say, sorry, that is not a valid direction. Okay. This is what we call a switch statement. It's also sometimes called a case switch or a switch case statement. You can call it what you like. I recommend getting used to it being called the switch statement because that's what they use in the textbook. Okay, so we call it the switch statement. Okay, and there are quite a few different ways we can work with this, and we'll experiment with it a little bit more next week before we move on to what I think is a particularly interesting part of chapter 1. Okay, for now though, let's leave the lecture there. So we'll pick up with switch statements next week. For now though, I do want to introduce you guys to this other website. Also quite a nice, useful one, I think. A good way for you guys to learn and practice beyond what we can cover in a single lecture if you have the time. And I'll occasionally recommend maybe that you guys explore one. So the website is called codewars.com, codewars.com. Okay. And if you visit codewars.com, you'll appear on this page here that I have open currently. Okay. It has a bunch of different languages that you can choose from. So we are obviously working with C#, which is right there. So you click on C#. And when you click that, before it allows you to sign up, they have like a little initiation challenge. And what's great about this initiation challenge is that it's pretty much exactly what we learned today. Okay. The solution to this initiation challenge is one of the operators that we learned today. So you just have to somehow solve this little puzzle that they've specified here. If you're having too much trouble after a little while, you're welcome to WhatsApp me, but do think about it. I think you guys will find that you'll be able to solve it. So they've got this little initiation challenge. Once you solve that initiation challenge, you'll be able to sign up for the site and log in. I'm just going to log in to show you, because obviously I've done it. So I'm just going to log in to show you what the site allows you to do. So I'm just logging in here to my account. And so what the site does is they have a bunch of like challenges, okay? And it's sort of organized. I don't know if any of you guys have done martial arts before or something. They split the challenges into different forms that they call kata, okay, kata. So it's like individual little challenges. Each challenge is called a kata. They are split over 8 different levels defined by Q. So 8Q is the easiest. 8Q is the easiest. So we can start with that since you guys are still gaining familiarity with C#. And you can see that there are a bunch of different 8Q challenges. And as we go through the course, for now, the initiation challenge is relevant enough. But as we go through the course, I'm going to recommend, just as we go through, different kata that you can do that will explain the topic that we have just done. Okay. So before next week, I'd like if you guys could finish the initiation challenge. So finish the initiation challenge, create an account, and maybe just familiarize yourself with how everything works, and we'll proceed on with these kind of thing next week. Okay. So yeah, and yeah, you can, it's quite cool. You can search, you can do it, they have, like, you can see this is n divisible by x and y. You can see that you can do this in so many different languages. They have many different options. We would obviously choose to do it in C#. So you can open up the kata and they give you a little description of what you need to do. And you type the code that you want to evaluate here. So you solve the puzzle in whatever the way you want, and you can test and actually submit. Okay, and they give you the little test cases that they're running over here. All right. So I think it's quite a cool website and quite a nice way to improve your ability to program. So I did want to just introduce you guys to it. And as you go through the different kata, I only just created an account. So I've just been playing in Python and C#, finding some good relevant kata that we could do. And so as you go through, they give you like points. They count the number of kata that you've actually completed, you know, track what languages you're best at. And like some companies actually do this now. So they give you Qs to solve because some of them are particularly challenging. Like the Q1 programming challenges are exceptionally difficult. So yeah, quite a nice website that I would like you guys to sign up for and gain some familiarity with, because I will make reference to some of the kata occasionally. Okay, cool. That explaining Code Wars was way faster than I thought it would be. I don't think there's much time to cover more than we have done so today though. So unless there's any other questions, I'll stay on the call for a little while longer. If any of you guys are having any trouble, then you're welcome to ask. Oh, for those of you, because I know a lot of you did join late, please post your names in the chat. For those of you who have already done it, you don't have to do it again. But please, if you haven't, post your name in the chat so that we can fill in the register. Next time I'll have the like a proper Google Sheets register that I'll be able to fill in at the start of the lesson. But I didn't have that set up this week. The center manager hasn't given it to me yet. So please just type your full name in the chat if you haven't done so already, so that I can mark you on the register. Or rather, like any name that can identify you for Brighter Futures is fine. Doesn't have to be your full name. Okay, cool. So yeah, I think that's it for today, guys. And yeah, thank you for coming. And see you next week. And good luck with the initiation challenge on Code Wars. Please do it before next week, and just sign up. And if you want, you can WhatsApp me, and I'll give you a hint if you like. But I think a lot of you will be able to do it if you think back to the different operators that we covered today. Okay. So yeah, thank you for coming, everyone. If you have any questions, feel free to ask them now, and I'll answer. But otherwise, yeah, have a good weekend and enjoy the rest of your day, and a good week, of course. Okay, I guess there's no other questions. So yeah, goodbye guys, for those of you who are still here. Cheers and enjoy your weekends, eh?